Hey everybody! So today we're going to learn about angle bisectors and midpoints. And I know your favorite question to ask is, when am I ever going to need to know this? Well, these two things actually might really come in handy because you never know. You might be stuck on a deserted island back here and need to meet your buddy on the island across the ocean. And you might want to decide to meet halfway. And that actually happened to me. You never know. And if you're into sailing or boating or flying, you're going to need to know how to find an angle bisector because that's how they decide and determine wind currents and vectors and all sorts of things that you actually might need to know later in your life. So today we're going to talk about two things, angle bisectors and midpoints. And basically these problems are pretty straightforward. You just want to pay special attention to your notation as well as what the problem is asking you to find. And that's really where kids get tripped up with these problems. So first of all, what does bisect mean? Well, bisect means to divide something into two equal parts. So two equal parts means divide it in half. Unlike when you were little and you argued with your little brother maybe about who got the biggest half of a cookie, there is no such thing, right? Two halves have to be by definition equal. So if you're told that something bisects another thing, that means that it's dividing the angle or the segment, in this lesson's case, into two equal parts. So both would have equal measure. So the first term that we're going to talk about is an angle bisector. So an angle bisector is a ray that divides an angle into two congruent parts. So in this example, you always want to read what you're given. So we're given this information here that JK, ray, that's a little arrow, one-sided arrow there, so ray, JK, bisects angle LJM. So LJM, remember you're going to follow the letters, so that letter in the middle has to be the vertex of your angle. So LJM. And then we have ray JK right here. So since we know that ray JK bisects angle LJM, we can write both congruency statements and equality statements. And this is where you have to be really careful with your notation. So if you remember from the first few lessons in Unit 1, we talked about congruent and equal. So when we're talking about equal, we're talking about the actual measurement or the length of something or the value of something in degrees if it's an angle. If we're asked to write a congruency statement, we can write that angle LJK is congruent to angle KJM. And it doesn't matter what the order is of your letters here, except that this middle letter J, since that's my vertex, J has to be in the middle of this notation. And you'll notice if it's a congruency statement, remember it does not have the little m in front of it, and you're going to have a congruency symbol here. The other thing, if we were not given the actual words that ray JK bisects angle LJM, we can tell that that's the case because of these two little matching arcs, and those are congruency symbols. So that's telling me, just with those marks alone, even if I didn't have that information, I would be able to tell that this angle LJK is congruent to angle KJM. Okay, and then if we're going to write about an equality statement, now we're talking about the measurement of the angles. We weren't given any exact measurements like 20 degrees, but you can still write an equality statement, and that now we're using an equal sign, as you'll see right here. And there are really three different equality statements we can write. We can say that the measure of LJK is equal to the measure of angle KJM. So it's the same statement as above, just with an equal sign and the little m's here. Or we can say the measure of angle LJK is equal to 1/2 of the measure of the big angle. So measure LJM. Another way of rewriting that mathematically is simply put the 2 over here, multiply the 2 to the left side, and we get 2 times the measure of the small angle is equal to the measure of the larger angle. Okay, so example 1, we're going to start off super simple, but the key is for all of these problems, you really want to read the directions. So don't just skip over what it's giving you here, because otherwise you might solve it incorrectly. You might not know you have all the information that they're actually giving you. So here in the directions, it says each figure shows a triangle with one of its angle bisectors. So that's important. We need to know that. So then find the indicated measure. Okay, so if measure WYX, right, that's this big one, is equal to 24 degrees, then what's the measure of angle 1? Well, we know that angle 1 and angle 2 are equal measure. So we can say the measure of angle 1 plus the measure of angle 2, or another way of writing that is just 2 times the measure of angle 1 is equal to 24 degrees. So obviously the measure of angle 1 is equal to 12 degrees. Okay, we usually put a little box around our answer. Another thing, don't forget the degrees. So we'll say, don't forget your units. Well, on angle measures, degrees, that's your angle measure, and so that's what the units are when you're measuring an angle. Okay, next problem. They're going to get a little tougher, I promise. So again, we want to read the directions. So we're still working with angle bisectors. Find the indicated measure. All right, in this case, so I can go ahead and mark my triangle. That will be helpful when the problems get to be a little bit more complicated. In this case, I'm given that measure of angle 1 is equal to 45 degrees. We can mark it right here. So that means angle 2 also has to be 45 degrees. So then what are they asking me for? The measure of angle GEF. So that's the big angle, right? So 2 times the measure of angle 1 is equal to the measure of angle GEF. So the measure of angle GEF is just 2 times 45 degrees, which is of course 90 degrees. Put a little box around our answer, and that's that one. Pretty straightforward. Okay, so now they start getting a little bit tougher because we're throwing x's into the mix and some equations. So we just need to figure out what pieces go with what parts of the triangle, set things either equal to each other or add them up to equal the total value of the angle, and go from there. So on problem number 3, find x, and that's key too. Are we finding x, or are we asked to find the measure of an angle itself? So pay attention to that. So find x if the measure of angle 2 is equal to x plus 12. So I would go ahead and just write it right in here, x plus 12. And the measure of angle 1 is equal to 2x plus 5. Okay, so you guys probably know exactly what to do. Since angle 1 and angle 2 are congruent or equal measure, we can just set those equal to each other. So we have x plus 12 is equal to 2x plus 5, and we want to get our like terms together, so we can subtract an x over here. Let's see, I'll do it step by step here. So, and a lot of times we like to write it this way with x on the left. But anyway, so we get x equals 7. And then you can plug it back in to check it out. So if I add 7, if I put 7 back into this equation, 7 plus 12, is that equal to 2 times 7 plus 5? So all right, so we have 19 over here. 2 times 7 is 14, plus 5 is 19. So that's a good way that I can check my work. So my answer, though, I'm going to put in a box, x equals 7. In this case, I'm not asked to find the angle measure, so I don't have to show a degrees symbol there. You don't need units if you're just solving for x. Okay, so on to example number 4. Why don't you stop the video if you're feeling confident, just pause it right here and try it yourself. Okay, so example 4, again, we're asked to find x, so that's important. We're still told that it's an angle bisector. So we're given if measure of angle 2 is equal to 4x plus 7. And I know angle 2 and angle 1 are congruent, but now it's giving me the measure of angle GEF is equal to 9x plus 7. So GEF, and it, like I said, order doesn't matter, so what matters is that this E is the vertex. That's going to be in the middle, right? So I'm given one of the two angles. So if this is 4x plus 7, this is 4x plus 7. So I could set this problem up in two ways. I could say 4x plus 7 plus 4x plus 7 is equal to the measure of the bigger angle, 9x plus 7. Or I can write it as 2 times 4x plus 7, two of these, is equal to 9x plus 7. And then remember, when you multiply this by 2, it's a good idea to put this expression, 4x plus 7, into parentheses, because you're going to need to remember to distribute that 2 to both places. So 2 times 4 is 8, 2 times 7, 14, and then I'm going to set it equal to the other side. I usually do my x's first, so always subtract to the bigger side. You don't have to always go to the left. So 9x is bigger than 8x, obviously, so 9x minus 8x gives me x, and then 14 minus 7 gives me 7. So again, I got x equals 7. Lucky day, I guess, right? And so then just go back and make sure that all we had to do is find x, not the measure of the actual angle. Again, I can plug it back in to see if that works. So 4 times 7 plus 7, and I could do it the other way. Let's see, 4 times 7 plus 7 again. Is that equal to 9 times 7 plus 7? And what do you know? So I have what? 28 plus 7 plus 28 plus 7. So I'm going to get 70 on that side. 63 plus 7 is 70 on that side. So it works out. So that's a good way to check your work. Okay, so moving right along, example 5. So in this case, we were nice to you guys, and I gave you a little note here, right? Watch out for these. Usually, obviously, on a quiz or a test or your homework, it's not going to tell you that. So again, you want to go back and read the directions. So directions, find the indicated measure. What doesn't it say? It doesn't have anything to do about ray EP or segment EP being an angle bisector. So don't assume that every single problem you see, especially after you get out of tonight's homework and you're going back to a unit review assignment, you can't assume that angle 1 and angle 2 are equal or congruent. It doesn't tell us that in this case. So it's going to give you more information on these types of problems because I can't set angle 1 equal to angle 2 because I don't know that they're congruent. But I do know that angle 1 plus the measure of angle 2 is equal to the bigger angle, FEG, right? So FEG is telling me right here that's 40 degrees. So this is a lot more like the problems you had a little bit earlier in the unit. So I have angle PEG, that's angle 1, if we just want to write it there. And then FEP, that's the measure of angle 2. So angle 1 plus angle 2 is equal to the measure of angle FEG. And then I can just substitute in the terms here. So 3x plus 1 plus x plus 3 is equal to 40. So in this case, I'm going to combine my like terms. So I get 4x plus, combine my constants, my numbers, 1 and 3, is equal to 40. And then you can solve this actually two different ways. We could factor out a 4 here if we wanted, but let's just go ahead. We'll subtract the 4. And then I'm going to divide by 4. So I get x equals 9. Okay, so now go back and say, well, what did they ask me to find? Don't just solve for x, because now it wants to know what the measures of each of those angles are. So I have to go back and substitute this 9 back into each of these equations. So I get 3 times 9 plus 1, 27 plus 1, 28 degrees. And that would be the measure of angle 1. And then the measure of angle 2 is equal to x plus 3. So 9 plus 3 equals 12. And then I want to add those up. Does that equal 40? Yes, it does. So in this case, this is my answer to that problem. Okay, so moving right along, now let's go to midpoints of segments. So a midpoint divides a segment into two congruent parts, or two equal parts. You can have a line, a ray, a segment could divide another segment. And if you have that, that would be called a segment bisector. So in the example here, it's just showing you a point. So the point, midpoint, that's a point that is going to divide segment AB into two equal parts. And we make the notation of two equal parts on a segment with two markings like that. If it were a line, a ray, or a segment dividing another segment into two equal parts, that would look more like this, where you would have a segment, let's call it segment RS, right? And then a line here, we might have line TU. And my midpoint of RS would still be right there. I could call it V, right? So you would have V is a midpoint of, and that's where you have to be careful, it's a midpoint of segment RS. But is V a midpoint of line TU? Think about it. What's the definition of a line? A line goes on and on and on and on forever, infinitely, right? So you can't cut it in half. There's no such concept of cutting a line in half, which is why you can't have a midpoint of a line, array, or array, but you can have a midpoint of a segment. However, in this case, line UT, and we would designate it like that with the arrows on both sides, would be considered a bisector. Okay, and then just like with the angles, we can write congruency statements and equality statements. So remember, with line segments, you want to use the bar over your letters when you're working with congruency symbols. So the little squiggly over the equal sign. So we have segment AM, this part, right, is congruent to segment MB. Now, if we're going to write an equality statement, notice there's no line over the AM and the MB. When you have an equal sign, you have no line over them. So this is saying the measure of segment AM is equal to the measure of MB, like 2 inches is equal to 2 inches. And we can also write equality statements like we did with the angles. So we can say segment AM is equal to half the measure of the whole segment. AM is half as long as AB. Likewise, 2 times MB is going to be equal to the whole. Okay, so let's do just a few problems with line segments and midpoints. Again, just a reminder, always read the directions. I know it sounds crazy, but you might read past something you need. So first of all, it says draw and label a line segment with the information given, and then find the indicated measure. So I have to do two things here. All right, so B is the midpoint of segment AC. So I'm going to make AC, and I'm going to connect my dots. And I'm going to try to put B right in the middle and make it a point. So B is in between and is the midpoint of AC. So I could mark my notation like that so I remember that they're congruent. And then AC, the whole thing, is equal to 3x plus 4. That goes to the whole distance. And BC is x plus 8. Find AC. So it's not asking me just to find x. I have to find the measure of the whole. So I can have x plus 8 plus x plus 8 is equal to 3x plus 4. Or once again, I can write it as 2 times the little guy is equal to 3x plus 4. So remember, when I do it this way, I have to distribute that 2. So I get 2x plus 16 is equal to 3x plus 4. I'm going to subtract to the right because this one's bigger. So 3x minus 2x, I get x. 16 minus 4, I get 12. So x equals 12, but that's not what it wanted me to find. So I have to go plug it back into this equation. So 3 times x, which is 12, plus 4 is equal to 36, plus 4 is equal to 40. Okay, on these problems, we didn't get any units here. But if we were given things like inches, like if it said find AC in inches, something like that, we would have to say 40 and then put our units here. Okay, so you just don't want to forget that. So anyway, we would say at the end here, AC with no line over it is equal to 40 and then whatever our unit measure is. Put a box around our final answer. Okay, moving right along, we're almost finished here. So again, I'm going to read the directions, draw and label a line segment, find the indicated measure. So why don't you pause it here and see if you can do it. All right, let's give this a try. So M is in the middle of A, B. M is a midpoint. Those are congruent. So in this case, I'm given AM is 2x plus 6, and MB is 3x plus 3. Find the whole thing. So what do I do? Yeah, I just set them equal to each other. Again, I keep subtracting to the right. I guess that's how all these problems are. So AB, now I want to find the whole length, right? So easy way to do that, just plug it into one side. So 2 times x equals 3 plus 6. 6 plus 6 is 12. And then I have to multiply that times 2. And I get 24. So AB is equal to 24. And again, I wasn't given units, but if I had been given inches, centimeters, millimeters, kilometers, anything like that, I would have to put units. Aha, challenge 1. All right, so let's try this one. Q is the midpoint of DR. Here's Q. Let's see, I should draw my line first, my segment first, instead of trying to pick the middle. So DR, DQ is equal to x squared. And QR, find the possible lengths. Aha, this is a clue right there. Anytime you see an extra S there, you might get 2 answers. So find all the possible lengths of DR. So I know these 2 pieces are congruent, so I'm going to set them equal to each other. But wait, oh my gosh, what do I do now? How do I do these kind of problems? So think about it. How would you solve a quadratic like that? Right, so we have to set everything equal to 0, get all the terms on one side, and then factor and solve for x. And we should get 2 answers. Anytime that we have x squared in the problem, we should get 2 answers. The only time we would get 1 answer is if it's the same number. So let's see what we get here. So we get x squared, and then I'm going to get minus 2x minus 24 and set that equal to 0. And then I'm going to factor this out. So I'm going to have and this is a minus, minus. So that means I have to have two different signs, because that's the only way I can multiply two numbers together and get a negative number there. So I want to think about, well, what are the different combinations that I can multiply together to get 24 and get a difference of 2? So if it helps, if you're a little rusty on your factoring, you want to think about all the different combinations and the factors that multiply together to give you 24. So if I just list them off to the side, I have 1 times 24, I have 2 times 12, I have 3 times 8, and I have 4 times 6. And over here, I don't have a leading coefficient. My leading coefficient is 1, so this would just be 1 times 1. So I have 1x and 1x. So since I have two different signs here, I have to find the combination that when I multiply them together, the difference is 2. So it's obviously this one. And then just as a refresher, remember that whatever the sign is here, that has to go with the bigger of these two numbers. So since that's negative, the 6 is going to go here and the 4 will go there. And then I'm going to solve for x. So to solve for x, I just say x plus 4 equals 0. I set each factor, each set of these equal to 0 and solve. So I get x equals negative 4 and x equals 6. Okay, so now, first of all, it's asking me for the length of dr, not just x. But we have to go back in and check these. Anytime you have an x squared, you have to make sure it comes back with a positive length. So I'm going to plug my numbers back into this one to make sure it works right. So if I have 2 times negative 4 plus 24, that gives me negative 8 plus 24. So I get 16 over here. So that works fine. I can have a length of 16. That's fine. So in this case, if I have 16 and 16, then dr is equal to 32. But I also have that possibility that x could be 6. So I'm going to plug x equals 6 back in to this equation too. So I have 2 times 6 plus 24. So I get 12 plus 24 is, oops, I'm running off the page here. I get 36 down there. So I get 36 and 36. So 36 and 36, I get 72. So I'm going to add those two together. So either of those work out to be correct answers. So anytime you see a problem with x squared in it, you will always get two answers when you factor it out. But you have to make sure that if you get a negative answer, you have to plug that back into your equation and make sure it makes sense logically. Because in geometry, we're not going to have negative lengths or negative angle measures for that matter. Okay, we're almost there. Just two more quick problems. So be careful on this one. So read the directions. Draw and label a line segment with the information given. Then find the indicated measure. All right, so let's read the problem. T lies between G and L on segment GL. Find GL. Does it say anything about a midpoint? So here I have segment GL, and I just know that T is somewhere in between. I don't even know which one's bigger, right? So GT is 2x plus 6, and TL is 6x, and GL, the whole thing here, is 12x minus 1. So I'm just going to add these up. I can't set those together and solve for x. I have to add them all together and set them equal to the total. So add up my x's first, so I get 8x plus 6. Oops. 12x minus 8x is 4x. And then I have a 6 over here and a minus 1. So I'm going to add the 1 to the other side. 6 plus 1 is 7. Oh no, I'm going to get a fraction. Is that okay? Yeah, that's okay. So then I need to find GL. So I have to plug my fraction back into the whole number here. So I'm going to have 12x minus 1. So I'm sorry, I didn't write that right. 12x minus 1. There we go. Different, right? So 12x, 12 times 7/4 minus 1. So I want to do this part first. Easiest way, just simplify, right? 12 divided by 4 is 3. So 3 times 7 is 21. Minus 1 equals 20. So I get GL equals 20 units. And that's it. So the mistake that students tend to make on this one is we've been doing midpoint problem after midpoint problem after midpoint problem, and they say, oh, I'm just going to set these two equal to each other because T must be a midpoint, so these must be equal, and then find X and then find GL. Well, it doesn't work that way in this case because it doesn't tell me that T is a midpoint. It only tells me that T is somewhere between G and L on the segment GL. Okay, last one. So when you have problems like this, are points C, D, and E, are they midpoints given the following diagrams? Why or why not? So think about it for a second. What do you think about this first one? Is C a midpoint? No, it's not a midpoint. Why? Because this is not a line segment, it's a line. So you can't have a midpoint of a line. All right, what about D? You guys are too smart. No, because FD is a ray. Right, so we would write it like this. FD would be a ray. You can't have a midpoint of a ray. You can't have a midpoint of a line. What about E? It doesn't really look like they're equal there. This looks a little bit skimpier than that side. Okay, so that's a lesson that we have to go with the markings. So if we see these two markings, that means that they're congruent. So I could say RE with the line over it is congruent to ES, or RE is equal to ES. So yes, E is a midpoint in that case because those markings tell me that E is dividing segment RS into two equal parts, two congruent parts, and that's the definition of a midpoint. Okay, so that's it for today. Hope that helped. It doesn't seem very hard. You just want to watch out for the directions. Make sure you know what you're solving for. Are you solving for X, or are you solving for the actual measure of an angle or measure of a segment? And make sure you know what you're given before you start the problem. All right, great. Good luck. Ooh, and I almost forgot to tell you, thanks for getting this far. This is a picture of the island where I actually was stranded and had to find the midpoint between the two islands that were closest so that we could meet the French Coast Guard. It's off of Guadeloupe. So yes, the French Coast Guard rescued us, and that is a story for another day. Thanks for listening.